Hello everyone, welcome to Chip Confessions. In our design verification course for batch 1, till now we have completed 4 sessions and this is session number 5. Let us see in this session what are all the things we are going to learn. So we will be seeing the common structure or the outline of Verilog design code and then Verilog test bench code structure. That is, we will be seeing the outline of how Verilog design or RTL code looks and then the outline of how Verilog test bench code looks. Why we are learning this? We are learning this because once you start getting acquainted with the data types or the modeling styles and with different styles of coding and all, this will be helpful so that you can directly apply them so that you can write a meaningful code. So in this session I just want you to introduce with the coding structure for design and coding structure for test bench. No matter, like, if you do not understand also, it is totally fine. Only thing is I just want you to know how the design or the test bench code looks. We are not taking any in-depth example and all. We will be just generally looking like how they look and all, means how the outline looks for both design and test bench code. Let us see them one by one. First we will be seeing Verilog design code structure. So in Verilog design, as I said, we will be having something called as a module. So no matter how small or big your design is, it should be enclosed within a module block. So module is nothing but a basic building block of your design or test bench code, without which your code will not get executed. Means in the C coding you might have seen, we will be using like hash include stdio.h and then hash include conio.h, and after that we will be using like int main or void main. This is how we use, and then after that in between two parentheses we will be writing whatever the code we want to write. In the same way, in module, in Verilog we use module. This is the code which synthesizes your design or the hardware block. This module will get synthesized as your hardware. So without this module your code does not have any meaning. So module is the basic building block for your design or test bench code or any code you write in Verilog. No matter you just want to display a statement, no matter whether you want you want to add two numbers or you want to display any number, or you whatever you want to do, no matter how many lines of code, whether it is 1 line code or 3 line code or 20 lines code or 2 lakh lines code, that should be enclosed within your module block. So in Verilog, module block is very much important. In the C code or in the C language or C++ language, how without main your code will not get executed, in the same way in Verilog, without module block your code will not get executed. So no matter whatever the design you have, you can or you have to write within the module block. So first is the module keyword. Module is the keyword. You can't use this word apart from apart from describing a module. So module is the keyword, and then you have to give the name of the module. This name is user defined. You can give any name apart from the defined keywords. Like you can't keep the module name as module only, because that will throw an error. You can't use any of the keywords. We shall see the list of the keywords in Verilog in coming sessions. So now you have to give the keyword module, and then you have to give the name of the module, and then you have to take something called as port list. Port list inside two parentheses. So in between this open and close brackets or open and close parentheses, you have to include something called as port list ending with a semicolon, and then in between this you have to, whatever the code you want to write you can write, and you have to end with end module. So one thing what we have to keep it in mind is, I hope you know C language or C++ language. There what we do, for any block we will be enclosing them within this pair of curly braces. But in Verilog what we do is, we do not use this pair of curly braces or any other brackets. What we use is, to enclose any block we will be using begin and end. And this is for the blocks, like we will be seeing a few coding blocks in our further sessions. For that you have to use begin and end, and for this module you have to use end module. You should not use begin here, but you have to end with end module. So how our design code looks is, first you have to take the module keyword, then you have to give name of the module, which is user defined name. You can give your name also, any name you can give, and then you have to write something called as port list inside two parentheses and end with a semicolon, and then end this block with end module. So what is this port list? This port list is nothing but, we should take an example design now. We have a design here, okay, and this is your design. So we have something called as port list. How we can include in your design? Your design means it should take some inputs and it should give some outputs. So it should take some inputs and it should give some outputs, and the direction will be like this. You are giving input here and you are taking output from here. So it means your design is communicating with the external world. Whatever the inputs we are giving, that we are giving here, and we are taking the outputs from here. So this is where you are giving the input and this is where you are taking the output, and your design is doing whatever the calculation or the function it has to do, that your design will be doing. So what is port? Port means the entry point or the exit point in your design which is communicating with the external world. Or port is nothing but an opening or a communicating means for your design, so that your design can communicate with the external world. So this is your external environment, and this is your design, and your design is communicating with this outside world with the help of this port. How your body is taking your food? With the help of your mouth. So whenever you want to eat food, you will take food through your mouth. So your mouth is the input port. So whenever you are taking food, your mouth acts as a input port. So you are eating the food, you are taking the food from the external world and you are feeding it to your body through your mouth. That is what your input port is doing here. Means whatever the input, it may be string, it may be any number, or it may be any kind of inputs, any kind of values you are giving to your design, that will be given through this entry point, which is called as input port. So this is your input port. Your design through which it is communicating with the outside world will be called as port. And if you are giving the values towards your design, it is called as input port. And if you are taking the values outside of your design, that is called as output port. So basically we have input ports and output ports. Input port is something where you are giving input to your design, and output port is something from where you are taking output from your design. That is what your ports are, and this port list will contain that only. So what your port list contains? Your port list contains input, port list and output port list. So no matter how many ports you have, you can have as many number of ports your design can have. If you have 100 number of input ports, you have to define here 100 number of input ports. If you have 100 number of output ports, you have to give 100 number of output ports here. So your input ports and output ports are the ports through which or the entry on the exit points through which your design is communicating to with the external world. So the module, now it is, you have a module and then name of the module, you have module which is a keyword, and then name of the module, and then you have something called as port list which is input port list, and then output port list, and then ending with semicolon and then end module. This is how your module beginning and module ending looks like, and in between this you have to write the logic of your design. If you are adding two numbers, you have to add two numbers. If you are subtracting, if you are dividing, or if you are doing anything, you have to include within this. That we will see whenever we are taking up some examples. And if you want to declare any of the extra signals, that also you can declare here. Any signals or variables you want to declare, that you can declare inside this. So this is how your outline of module looks like. And whenever you are writing input port list, you have to use the keyword input and then name of the variable, and then whenever you are taking output port, you have to give the keyword output and then you have to name the variable. So this is how it looks like. Means by defining your port list here, you have to give input and the variable name, and then whenever you are defining output port, you have to give output and then you have to give the variable name. And we have one more thing which is called as in-out port. So in-out port is nothing but which acts as both input port also and then output port also based on the context. Means whenever you are giving inputs, it acts as an input port, and whenever you are taking the output, it acts as a output port. So whenever you are giving input, it acts as an input port, and whenever you are taking the output, it acts as an output port. So it is called as in-out port. It is called as in-out port. So what we saw here is port is something, entry or exit point in your design through which your design is communicating with the outer or the external world. And we have three kinds of ports: input ports, output ports and in-out ports. Input port is nothing but through which your design is taking the value inside it, and output port is nothing but the port through which your design is giving out the value, and in-out port is nothing but the port which can either take the input or it can even give the output based on the context. This is how we saw the ports, and this is how your design outline looks. And one more thing is, you can include as many number of modules in your design. Even you can include like hundreds of modules in your design, but one thing what you have to keep it in your mind is, you should have one main module which is synthesizable. Like if you are using hundreds of modules, you have to include them in a single module, inside a larger module or your main module, so that your design will get synthesized. Otherwise it will create some like synthesizable issues. Like it will be a confusion only. Multiple modules you are using and multiple modules you are synthesizing, and if nowhere they are related with each other, then it is chaos only. So you can include as many modules as possible, but the thing is, one main module you should have, and that module should be synthesizable, and that module can contain the instantiation of these sub modules that we all see in our further session. What is a sub module and what is instantiation and all that we can see. So this is how your design looks. And next is the test bench code, and how your test bench code looks. So okay, so we shall see how your test bench code looks. So we have got, let us say in our design we have one input port, and then we have one output port, and our design is doing some calculations or anything. So in your test bench you are writing it to test whatever the design you have written. For example, if you have written a design which adds two values, then if you have something called as A and B, and you are taking the sum as sum, then in your test bench you should give values to A and B, so that you can check the value of sum. So that sum is equal to the expected value. Like if you are adding 2 plus 2, it should be equivalent to 4. And whenever you are giving those values to those two variables A and B, like if A equals to 2 and B equals to 2, sum should be obviously equal to 4. Why we have to do this? Because whenever you write a design, you should check whether the design is working or not. And in Verilog, we write a design in such a way that we will not be initiating or initializing any of the variables to take any some values. Sometimes we can use default values also, but apart from that, usually we will not provide any values in the design. Why? Because if we provide any values in the design, that design will be constrained, or that design will be constrained to that values only. It will be confined with that values, and it cannot work for any other values. But what we will do, we will take some variables, we will write the logic, and yes, we will complete our design. And in the test bench, what we will be doing, we will be giving all the values as possible, so that we will be checking thoroughly whether the design is working properly for all the range of values or not. So test bench is nothing but a structure which we use to test your design thoroughly, so that your design is working for all the range of values it can take. So what we are doing here is, we will be seeing how Verilog test bench code looks. Obviously again this is also module and the name of the module, and then here we are not giving any port list. For design only we will be giving the ports as input or output or in-out ports, but for test bench we are not giving any of the port list. Then what we are doing? What we are doing is, we are ending with end module, and then what we will be doing is, we will be connecting your design with our test bench variables. how we are going to do this. For example, let us take your design. Your design has A as input and B as output. So what we will be doing is, this is your design and we have A as input here and then B as output here. So we are giving input A and we are taking output B. And what your test bench is means, this is your test bench and this test bench, this is your test bench, and here we are connecting, we will be having some variable A here and we will be connecting these two variables, and we will be having variable B here and we will be connecting these two variables. So it is like we are connecting a bridge. So this is how where your design and test bench connect each other. We are connecting input with the input and output with the output, and we will be checking those values. So your test bench contains module, name of the module, and we do not contain any kind of ports, and we will be ending with end module, and here we will be connecting the test bench variables with design variables. So in the test bench we will be declaring or defining few variables which are as same as your design. So if your design has 5 inputs, we will be declaring 5 input variables in the test bench. If your design has 500 input variables, we have to define 500 input variables in your test bench. Like that it is. So whatever the design has, same thing will be there in your test bench. Only difference is your design will not assign any values to our inputs, but in test bench we are assigning values to your inputs and we will be checking the outputs. So your module test bench will contain the module name and name of the module and open and close parenthesis. This is optional actually, you can use parentheses, or if you do not use also it is fine. Means this is used only if we have any port list. We do not have any port list in test bench structure or test bench coding, then we are declaring test bench variables here, and this should be same number as design. Okay, and then what we are doing is we are initializing, or we are giving values to these variables, and as these variables are connected with the design variables, whatever the value we give here, it will go to the design, and here whatever the computation or the process, whatever the design is intended to do, that will happen, and then that value will be taken by B, and that B will go to this, the variable we defined in our test bench. Here we will be giving the input, here we are taking the output, and we will be displaying the output or printing the output, and we will check whether this output is correct or not. So we will take module and the name of the module of the test bench. This is for test bench module, name of the module, no port list, and then we end this block with end module, and inside that we will be declaring the variables which are as same as design variables. If we want any extra variables locally, we can even take that also. And then we will be giving the values, like any range of values that design can take, that we will be giving, and we call those input values as stimulus. And we will be giving the stimulus, means the values we will be giving, and based on that your design will work or design will give the output. And then we will be taking that output and we will be checking whether that is correct or not. So in the test bench we are declaring, and then with the module keyword, and then giving module name, then open and close parenthesis without a port list, and then ending with a semicolon, and then ending the block with end module. Inside that we are declaring the test bench variables which are in same number as design port variables. And then if we need any extra local variables, that also we can declare here. And then we are connecting those variables with the design variables which we called as DUT instantiation inside the test bench, because without connecting, if you just give the values, it will not work. So you have to connect this test bench variables with respect to the corresponding design variables, so that they can pass the values to the design as and when we assign them in the test bench. So we will do DUT instantiation, where we are connecting our test bench variables with the DUT variables, and then we will be assigning our test bench variables with some wide range of values or every possible values, so that that value will reach the design, and then the design will work on those values and it will give the output, and that output will be taken by the test bench variable, and then we can see whether that is working or not, and we will be displaying the final output or the result. So this is how our design and test bench code look, and this is how our design and test bench works. So yes, here we have a, this is for the design, actually design code structure. We will be having a module, and then we will be having a module name, and we have input port list, and we have output port list, and if we have any in out also, that also we can include, and any internal variables or something extra apart from ports, if you want to use any other variables, and these variables will not correspond to the ports, actually that is for internal calculation only. So internal variables, if we have, that we can include here, and we have to give the design logic, like this is the heart of your design, like how your design is going to work, and then we are ending this block with your end module. So this is the outline of your design structure. Then we will be seeing Verilog test bench code structure. We are just revising whatever we studied just before few minutes. So this is your module, and you have a module name here, means name of the test bench, and then we have open and close parenthesis, and then we have a semicolon at the end, and we are ending this block with end module. And then we have to give the variables similar as design, means whatever the number of ports your design contains, that many number of variables should be there. We can use any names, we can use same names, or we can use even different names also. And then we can have internal variables which are helpful in calculating some intermediate values. Then we have DUT or design instantiation, where we are connecting test bench with design. So this is where we are connecting test bench with the design, and then we are giving the input values to the design, that is nothing but applying the stimulus, and then we are displaying the result. So this is how your module test bench or the test bench module looks like. So this is how your test bench module looks like. So in this video we just saw how how the Verilog design code looks and how the Verilog test bench code looks, and what is the design and what is the test bench and what is the purpose of using the test bench or how the test bench works. From the next session we will be diving directly into the Verilog and we will be starting with our data types. And one more thing I just wanted to know, like your inputs is important regarding how this session should go. Like, should I confine the sessions for 5 to 10 minutes, or can I like explain thoroughly and let it be like half an hour? Because I'm not counting the time when I start explaining. It is like end to end I'm explaining. I'm not counting the time I should finish within 3 minutes, 4 minutes, like that. So I just wanted to know from your side how you are comfortable with, like whether it should be a short sessions or it should be a longer sessions, like how much time it can take, let it take, like that you are thinking, or you want only short sessions. Kindly let me know in the comment sessions, so accordingly we can continue in from our next session. Thank you for being with me, or thank you for being with me in this video, and yes, thank you. Happy learning, and yes, keep practicing from your side also. And if you need any if you need any slides or anything, you can put in the comment box so that I can add these things in description by putting the drive link. If at all you need, you can ask. Okay, thank you so much. Let us meet again in our next session. Thank you.